today we're going to try something a little bit new. So I've never done this before, so we're going to work together. It is really important that you do the worksheet that goes along with this. So by now you should have downloaded the Word document that goes along with this. That will be your notes, and you'll see some little blue lines. That's where you're going to type in the missing words. It's really important that you do that because what it does is it forces you to follow along and pay attention to the words. So let's give it a shot. Okay, so we're going to look at the different types of weathering, starting with the definition, of course. So weathering is the breaking down of rock into smaller and smaller pieces. We've got two different categories of weathering, mechanical weathering and chemical weathering, and each of these has a few different forms. So let's start with mechanical weathering. And mechanical weathering, as I said, was the breaking down of rock into smaller and smaller pieces. But what you got to remember is that this is strictly a physical process. Does not change anything about the physical makeup, or pardon me, the chemical makeup of the rock itself. So it would be like if you took a cookie and crushed it, it still tastes like a cookie. So there are many different ways that a rock can mechanically weather. Thermal expansion, exfoliation and pressure release, frost weathering, or biotic activity. Let's take a quick look at each of these. Thermal expansion. Thermal means heat, therefore we know this has got something to do with heating and cooling. Most rocks are made up of different types of minerals. We can see that when we look at them. These minerals will heat up and cool down at different rates. So you'll have one part of the rock that's heating up very quickly, and right next to it it's got something that's heating up much more slowly, and then right next to that is something that heats up quickly again. And all that's going to do, all that uneven heating and cooling over time, will strain the rock and it'll crack it and cause it to break. Kind of like what's happened here. Then we have exfoliation and pressure release. So for this, I need you to remember back to what we learned about when we talked about volcanoes, the batholiths and laccoliths. Okay, so the magma chambers of those volcanoes, they're extinct now, but the magma chamber is still there. So the magma chamber, deep inside the earth, it now has nothing to do, so it cools down and hardens. So we've got these batholiths or laccoliths. Now, underground, these things are under enormous pressure. So in order to find isostasy, the internal pressure of the rock will match the external pressure that's pushing on the rock. All right, so over time, that balance is created. However, what happens when the land erodes? Now the rock mass is exposed. It's no longer under the pressure, and now it expands. As I've said here, kind of like if you removed a girdle. So because the rock mass expands, but rock itself isn't stretchy, so the surface of the rock cannot deal with this expansion, and the only thing it can do is crack. So here's an image, and I love that we've got a little dinosaur because it tells us about the time period we're talking about. So here's your batholith or your laccolith, and it's got all of this external pressure pushing on it, and therefore to achieve equilibrium, it of course has to have an internal pressure that will push against it. So over time, so we go from the time of the dinosaur to the time of people, all of this erodes. So now you've still got the the external pressure here, and therefore you've also still got the internal pressure, but there's no external pressure any longer in this area. And so the internal pressure exceeds what the external pressure, therefore it pushes out. And as it pushes out, it causes the surface to flake away. And it is a rather dramatic overall effect, as you can see. Frost weathering is also called ice wedging. And this is a real simple idea. Here you've got a crack and you've got water that gets into the crack. Water, when it freezes, expands. As it expands, it forces the crack a little bit further open. And then this happens again and again and again. Remember, this is going to happen over time. And eventually, a part of the rock will break away. And there is a very dramatic view of that happening. Finally, we have biotic activity, and that's basically anything to do with living things that cause the physical breaking down of rocks. So if an animal skitters across a rock and causes some of that worn material to fall away, they've helped with that biotic activity. But roots are a big deal. Roots are a lot stronger than most people think. They can grow into small cracks, and as the root grows, it forces the crack to open wider and wider, and eventually this is going to break the rock apart. If you have a look at any of those old ivy-covered buildings in Europe, at one point people had tried to remove that ivy. Turns out you really can't without severely damaging the front of the house or of the building, because the roots of the ivy have clung in so tightly that they will actually pull the rock away. But insects and animals can also cause some of this weathering. What they do is they burrow and they tunnel, and they expose rock that is underground to the air, to the water, before erosion would naturally get at it. So now, even though it's underground, it can still weather. All right, so all of these other processes can still happen, even though it's not at the surface, and that's because of the animals. And there's a very dramatic view of a tree that has, well, it is weathered the rock. So if we do change the chemical structure, so instead of just breaking up your cookie, you put the cookie into coffee. Well, now you're going to have a new product. It's not going to taste like a cookie anymore, right? So, chemical weathering happens when the chemical structure of the rock is changed and the new product is worn away. Chemical interactions can cause rocks to dissolve. Yeah, I know, hard to imagine, but rocks do dissolve. So, chemical weathering takes a lot longer than mechanical weathering. It happens faster in hot climates than in cold climates, but it's still slower than mechanical weathering. Main agents of chemical weathering: water, acids, and oxidation. So let's look at water first. So many minerals are very soft and are water soluble. Examples are potassium and calcium. So when the erosion exposes those pockets, so all of a sudden the calcium and the potassium aren't encased in rock anymore. Now they're exposed to the air. So now water can get in, dissolve these things, and then wash away. Now, water can also interact with different minerals to create new compounds, and a good example of this is when feldspar mixes with water, clay is created. Acids are kind of a big deal, especially now with climate change, but industrialization has certainly sped up the process. So many of the elements in the air are actually acidic. So when they combine with rainwater or other forms of precipitation, they form a mild acid, and we are talking very mild. The mild acid over time can wear away the surfaces of rocks, buildings, etc. So what are some of these? Well, carbon dioxide is something that we find naturally in the air, but when it dissolves in water, carbonic acid is created, and carbonic acid will eat away at things like limestone and Tyndall stone, but again, it takes a fairly long time. Now, carbon dioxide is found in air normally, But since the Industrial Revolution, the amount of carbon dioxide being added to the air has increased exponentially. So the amount of carbonic acid that is coming down as acid precipitation has also increased exponentially. Similarly, sulfur dioxide links up with the oxygen in the water, creates a sulfuric acid. This sulfuric acid will also fall as acid precipitation. Same thing will happen with nitrogen and nitrogen gases, by the way. Finally, you've got mosses and lichens. Now, you see these growing along or on rocks along riverbanks, but when the moss gets inundated with water, it actually will form a mild acid, a plant acid, and that acid will eat away or dissolve the layer of rock that the lichen is sitting on. And finally, we have oxidation. Oxidation is what happens when oxygen links up with different minerals, and what that creates are oxides. Now, the oxides tend to be softer than the original mineral, and it will crumble easily. The best example of this is when iron links up with oxygen, so iron oxide or rust is formed, and as you know, rust or iron oxide crumbles away, and that's why your iron will dissolve. Well, it doesn't dissolve, but you know what I mean. It breaks apart. So what have we learned? We've learned the difference between weathering and erosion. We have learned that there are two categories of weathering. They are mechanical and chemical, and that there are different forms of mechanical weathering. So you have learned what the different forms are, and you have learned about the different agents of chemical weathering. And hopefully that is going to stick. I don't know how much longer we're going to have to do this kind of learning, but hopefully this has worked out well for you. Stay safe, guys. Talk to you another time.